Ahmed Abdelhadi, and today we are gonna explain this dataset. It's called the Internet of Things Agriculture 2024. It was done by Muhammad Ismail Lifta from the University of Tikrit, Iraq. Uh, the data were obtained from greenhouses, probably in Iraq, and here is the amount of data we have. These are the number of rows. And initially, there is 13 features, but we're only gonna discuss four today. The four features we're gonna discuss uh, are temperature, humidity, water level, and the nitrogen level. Um, the objective of this data set was to use Internet of Things to monitor various environmental factors in agriculture fields. The data were collected to improve the decision making for smart farming practices, combines elements of networking technology such as networks, wired and wireless, and sensors, also Internet of Things, with different applications. Uh, there's a reference of the dataset, the one I got it from Kaggle. It's available. Um, so yeah, this dataset contains information gathered from Internet of Things sensors, such as we said, in greenhouses used in agriculture fields. It includes various metrics such as yeah, nitrogen level, temperature, humidity, water levels, and way more environmental factors that all affects crop growth, which makes it really useful. The dataset focuses on the interplay between agriculture and Internet of Things, allowing for real-time monitoring of various parameters essentials for smart farming. Here is the features we're going to discuss and their descriptions, and they're all from the same dataset. This dataset can be used, or this amount of data we have here, it's a good amount of data. It's not a big dataset in memory wise. It's around, yeah, it's written here somewhere. Yes, the dataset is memory wise is 2.48 megabytes, but it has very useful data that we can use initially and potentially for yield prediction in agriculture using environmental factors and historical data we obtain from such a dataset can predict crop yields. Accurate yield forecasting helps farmers plan harvesting and optimize resources allocation. And this, of course, affects cost. Also, we can identify the needs of uh, of the plants and create predictive models using machine learning to forecast water needs based on humidity level or social moisture and other factors. Or we can use it to optimize resources and investigate how environmental factors affect resource usage, since we have data about water and fertilizers and extra, and create optimization strategies to reduce resources consumption without compromising crop health according to the data we have. Here's an extra. Uh, we can use the time series analysis to track seasonal changes in temperature and their impact on agriculture, since we have uh, time by time, as we're going to see here, time by time data. Sorry. yeah, here is the data we have. As we can see here, these data were collected from 27th of November 2023. That's almost a year ago, until end of March 2024. Uh, here is the types of data we are discussing: temperature, humidity, water levels, and nitrogen levels. We're gonna stop here. Nitrogen levels are pretty stable throughout, yeah, throughout the whole, except for this part. Let's see. At December 2023, it dropped. It dropped here, as we can see here. It dropped. It dropping, kept dropping. Uh, so multiple readings are taken in a single day, as we can see here in the time row and the time column. Here is one was taken 5:36, 5:41, 5:42 a minute later. Uh, yeah, and yeah, temperatures. Of course, it varies. Yeah, we started with 41. It dropped, increased when needed, of course, and the whole thing is seasonal. Also here with the, what is this? Also here with the humidity, it's also seasonal. We can see it changing, and the water level is pretty stable, and nah, it changes. So yeah, basically this is it. I hope this is useful, and thank you so much.